You have worked with exponents before, so there shouldn't be anything new, but we maybe need a little bit of reinforcement just to make sure we got it all right before we keep going. We'll start out with 6 laws here, and we'll add one more once we get to the end. The first law is when you have the same base, okay, so A and A, those are the bases, and then each is to an exponent with multiplication in between. When you see something like that, you are going to add your exponents. For example, let's say we have x squared and x cubed multiplied together. Base is the same, the base is x. So we add those together, it becomes x to the 5th. The one that's similar to that people get confused is this one down here, law 5. This one, instead of adding your exponents, you multiply them. So, for example, say we have x squared all cubed. Here, there's just one base. Our exponents are right next to each other. We multiply them. So this would equal x to the 6th. So see the difference between law 1 and law 5. Now law 2 is similar to law 1, except instead of multiplying, we are dividing. And so in our answer, instead of adding, we will subtract. So this is when you subtract exponents. Let's do another example. Say x cubed is on top, x squared is on the bottom. So this equals x cubed minus 2, which is just x to the 1. All right, law 3 and 4 are very similar to each other, and their main concept is to distribute. All right, so this m goes to each part of that multiplication. So a to the m and b to the m. Let's look at that. So say we have xy all cubed. That's the same thing as x cubed and y cubed. It's supposed to be 3. All right. Similar thing happens up top with law 4. Again, we distribute. So the m goes to both the a and the b. An example of this would be, say we have x over y all cubed. So you get x cubed over y cubed. Now, the last law, it kind of stands alone. It doesn't have anything similar to it, but you should already know this, that anything raised to the 0 power equals 1. All right, so 5 million raised to the 0 equals 1. Let's use these to do some examples. Example 1, what should we do? We are going to distribute that squared to every piece based on law 3. So we get 3 squared, x squared squared, and y squared. Simplify that out, we get 9. Here we need to multiply based on law 5. So x to the 4th, y squared. That's your answer. So that was law 3 and law 5. All right, sorry about the double equal sign. Don't need that. What happens here with everything is raised to the 0 power, so it equals 1. That's law 6. Okay, next one. Go ahead and just look at your fraction here, just this part. What's negative 12 divided by negative 4? That is negative 3. Now, look at your variables. We have a to the 7th over a cubed. Well, we can say that's a to the 7 minus 3, which makes our answer negative 3a to the 4th. That was law, let's see, what was that, 2? Yeah, law 2. All right, let's go to number 4 here, getting a little more complicated. We need to distribute this entire part of the equation to the 2 terms in the back. So I'm going to write 3x squared, got that from right here, and now what we multiplied it by. So xy squared plus 2y squared from right here, and then by what we multiplied it by, xy squared. All right, let's see what we can combine in each term. So we can combine these two right here, so that makes 3x cubed based on law 1 squared, and here we've got the y's we can combine, so plus 2x y to the 4th. Now, these are not like terms, so you cannot combine them. They are not like terms, even though they have the same variables. We've got x and y. It has to be same exponents in order to add. So x cubed and x make it not similar. So these are not like terms. Here's your answer. Let's do another one with number 5 down there. Okay, with the 2, we're going to distribute it based on law 4 to the top and the bottom. The 3 we will also distribute based on law 3. So that makes on top a to the 8. We multiply those from law 5, and then b squared on the bottom times a to the 6. Multiply again from law, what was that, 5? And then b to the 6 as well from law 5. All right, now combine. Let's see. In our numerator, we have a to the 8th and a to the 6th. We add those based on law 1, so a to the 14th. And then b to the 6th over b squared. We turn that into subtraction, so it's like saying minus 2 right there. So we get b to the 4th. All right, whenever you're ready, let's go ahead and go to the back. If you're not ready, pause the video. So the 7th law is about negative exponents. So if you have a negative exponent, okay, so the actual exponent, the little number up there is negative, you can make it positive by just pushing it to the other side of a fraction. So if it is in the numerator, like here, if you push it to the bottom, it becomes positive. So let me show you an example just real quickly. Let's say we have x to the negative 2. That, push it to the bottom, the exponent becomes positive, so is 1 over x squared. Now it also works the other way. Let's say we have 1 over y to the negative 3. Push that across the line and it becomes positive, so y cubed would be what that equals. So you can go both ways with this, from top to bottom, bottom to top. All right, so let's simplify these. You can do these, like follow the steps in different orders, use the laws in different orders, so you may not think of it exactly the same way I do, and that's okay, as long as you get to the same answer. So I'm going to approach number 1 using law 1, which basically I'm just going to combine my exponents together since it's the same base, so I add them. So that gives me 5 to the negative 1. I don't want negative exponents, I want positive, so I'm going to push it to the bottom of the fraction. So 1 goes on top, and 5 to the positive 1 goes on bottom. So our answer is 1/5. All right, the other way to have thought about that was to say, go ahead and move this to the bottom of the fraction first. So your 5 cubed would stay on top, but then 5 to the 4th would go to the bottom. And then we could cancel this out and say minus 3. So you would get 1 over 5 as your answer. Okay, there's other ways to think about it too, just showing you. 2. All right, let's do problem number 2 here. Do we add or multiply these exponents together? Multiply, because there's only one base. So we get 2 to the negative 6. So push it to the bottom, so 1 over 2 to the positive 6, which is, I believe, 1 over 64. Okay, notice that just because I had a negative exponent did not make my answer negative. Those aren't really connected at all. Okay, it's just about the fractions. Let's go to number 3. We got lots of 8s here. I'm going to go ahead and, let's see, what do I want to do first? I'll go ahead and combine the top. So I add those exponents, so it makes it negative 8. And then I still have 8 to the negative 9 on the bottom. Let's flip it by pushing the numerator down. So that would be 8 to the positive 8. And then 8 to the positive 9 by pushing the bottom up. Okay, now let's see. If I move that to the top, it'll be negative 8. Okay, so 9 minus 8 is 1, so that just equals 8. Like I said, different ways to think about it. Okay, let's do number 4. That negative 3 goes to the 5 and to the 4. So we have 5 to the negative 3 over 4 to the negative 3. I'm going to flip it to make them positive exponents. So 4 cubed over 5 cubed, which is 64 over 125. Remember, your calculator can help you figure those out. And that one does not reduce. All right. Example number 5 actually has some variables in it, which is good. Let's see, what should we do? I'm going to just look at the numerator first. Okay, so what is 5 times 3? That's 15. Okay, and then put our x's together, so that'll be x, add the exponents to the negative 7. Now put your y's together. That's y to the positive 8 all over, got my just numbers, the coefficients, 8 times 6 is 48. Okay, and then let's see, I have one thing of x, so x to the 5th, and then y to the negative 4. Okay, so I've condensed it down to some, but we need to keep going. So 15 and 48, a 3 can come out of both of those. So that becomes 5 over 16. Okay, my x's, if I move this down to the bottom, it becomes a plus 7. So that x to 12th. I'm going to move my y up by saying plus 4. It was negative in the bottom, so it's positive in the top. So I have y to the 12th. Okay, I'm going to write it all out together. So 5 y to the 12th over 16 x to the 12th. Let me go ahead and do that one other time, that entire problem, just so we can see another way to do it. Okay, so the original problem was 5 x to the negative 4 y cubed over 8x to the 5th times 3x to the negative 3 y to the 5th 6y to the negative 4. Okay, another strategy you might take there's more options than this, is to make all the exponents positive first. So, let's see. Let's just say this is going to go down, this is going to go down, and this one's going to go up. That just kind of helps me out. So on top, I'll have 5 and 3, and then y cubed, I'm going to mark it out as I use it, and y to the 5th, and y to the 4th from moving this one up. Okay, then on the bottom, let's see, I have an 8 and a 6 and an x to the 5th already down there. And then I'm going to move an x to the 4th from right there, x cubed from right there. Okay, now simplify here. What is 3 over 6? We can reduce that. So this becomes a 1, this becomes a 2. All right, so I've got 5 over 16. That's good, since that's what I got on my first time I did the problem. Okay, and then y, let's see. 3 plus 5 is 8, plus 4 is 12. And then on the bottom, 5 plus 4 is 9, plus 3 is 12, so x to the 12th. So there's my answer for trying it a different way. Hey, got the same answer, that's good. So now you should be able to do your homework, and you've got lots of examples to help you, and let me know if you have questions.